Thank you guys so much. I just want to introduce myself. My name is Devin Feely. I am an anchor and a reporter for KPIX, the CBS station here in the Bay Area. I've been working for the station now for a little over 5 years, and you can see me very early every Saturday and Sunday morning at 6 a.m. to 7 a.m., and then I report 3 days during the week. But I wanted to thank you guys so much for inviting me, for allowing me to be your MC tonight, and just to give you a little bit of a sense of my background and history. I am a native of San Jose. I grew up in San Jose. I graduated from Bellarmine College Preparatory here in San Jose. And I am not an engineer, obviously. I am a journalist, but I am the son of an engineer. And my dad now, this year, will turn 80 years old. And one of the things that I have discovered is that there are two things that you forever are. And these are two things that my dad has been over the course of his life and will be forevermore, which is he was a Marine as a young man. He was in the Marine for 4 years. I think really kind of a transformative experience for him. And he is an engineer. And even at 79, turning 80, he is still just a semi-retired engineer who works for Northrop Grumman. Still comes in 2 days a week, trying to transfer all of the information and brilliance in his brain to a new generation of engineers, and still working on the big projects when they come down the pipeline. So he was very hopeful that he would get an engineer out of one of his two children. He got a journalist and a doctor. Didn't quite get an engineer. Maybe you can point to the fact that he married a school teacher and principal for that. Gave her a slide rule on one of their earliest dates. Somehow made it to the next date and eventually to 50 years of marriage. So anyway, I have a tremendous amount of respect for your industry and what you guys do, and for how you have written the present and the future of this valley. Now I want to bring up the leader of this organization, Yilka Masada. She wants to say a few words before we allow you guys to eat. Why don't you go ahead and take the stage. Give her a round of applause.
Only this, not this one. Good evening, everyone, and welcome to Silicon Valley Engineering Council 2020 Engineers Week Banquet. We are honored to have you all here tonight with us to celebrate Engineering Week 2020, organized by Silicon Valley this organization, founded in '89 by a group of brilliant engineers who thought about that in Silicon Valley should be created to organize two engineers together to gather different disciplines of engineers to share knowledge and experience and to make a big difference in the world for the better. So SVEC hosts every year this Engineers Week Banquet, and gather all the engineers of all disciplines together to share the evening together and to create a good bonds and connection and work together in the industry and as well at schools from young age to K-12 to college and universities, so we all can have a brighter future for generation, not just today, but generation after generation, and to pass it on along to generation to come. This year, with this banquet, we also celebrate the Discovery. Discovery is a program that has a lot of values to the society and to engineering, and to make sure that people understand what the engineering is, especially young girls, and promote them, inspire them to become an engineer. This year's Engineers Week is on February 16 to 22, and the Girls' Day is assigned to be the February 20. Started last year, there was also a Discovery Global Day for all engineers around the world to celebrate together. And for this year, 2020, that Global Engineers Day is on March 4. So we have this year's theme for Discovery is clean water, the clean energy, the future city, the brighter future for the cleaner cities, especially clean water. So we'll talk more about the Discovery and other things as we go along later on. But tonight we will also award many teachers that work in Discovery, and also many teachers for Keeper of the Flame programs, and also a lot of students that they can be our future engineers. But tonight we also gather here to award the Hall of Fame award to two great inductees, so that we can all together celebrate with them and thank them for the service to community, for the service to profession, and service to engineering. So now, tonight we will also have a lot of good things to say about organization, what we have done and what we can do. And I call upon all of you to join SVEC and work together.
Thank you so much.
You're welcome.
Yeah, we have an amazing program ahead of us tonight. We'll be honoring the career accomplishments of some amazing people, as well as encouraging that next generation of engineers. All of that is going to come in a short time, but for now, just enjoy your meal. We'll be right back. So the Silicon Valley Engineering Council is an umbrella organization. It has been described to me as an organization of organizations. It is something that is founded and rooted in the spirit of collaboration. And as all of the engineers and scientists in the room, and just anyone with iota of common sense can tell, any project of any significance is going to involve people of different disciplines. And it just makes sense for all of the different types of scientists and engineers to have a central clearinghouse where people can learn about other disciplines. And that is what this organization has done for the past 30 plus years. Now, obviously, an organization of organizations has a number of member components to it, and we want to recognize some of those first and foremost. So I know that some of these other organizations that you guys are probably seated together, let's just hear so we can kind of locate you in the room by the sound of your applause as we name you guys and go down the list. So, first amongst equals, we have the American Institute of Chemical Engineers. Oh, so you guys are kind of scattered throughout the room. Next up, we have the American Society of Civil Engineers, the San Jose branch. In the front. The American Society of Materials International. This table 3 has a lot of hats. Ah, Fred, a member of all the organizations. So the next one is actually the one that my father, who I mentioned earlier, who is a mechanical engineer, that he belongs to, the American Society of Mechanical Engineers. He will be heartened by that. The Electric Auto Association of Silicon Valley. The IEEE-CS Computer Society. The Computational Intelligence Society. The Solid State Circuit. and the IEEE East Bay chapter. A scattering of applause. The Society for the Advancement of Materials and Process Engineers. And the Northern California chapter. What would I skip? I'm sorry. That is my bad. I would not want to miss anyone. Oh, the Society of Automotive Engineers, Mid-California. Okay. My apologies, especially for a group that is as well represented and boisterous. Oh, yes, someone mentioned the women engineers. And that is a special point of emphasis. I know I was speaking with someone earlier in the lobby who was on the board who says that not only are we recognizing people who have already had amazing careers and made amazing contributions to their field, we're also encouraging that next generation. And it is a point of emphasis of the organization to encourage that next generation, and in particular, young engineers and scientists, women, and young engineers and scientists of color as well. So that is a very important recognition. Now, any organization that has served this community in this field for as long as this one has, it is not without the contributions of a lot of people who have been at the helm of the organization in the past. So it's my understanding that we have several of the past presidents of the organization. I would like you to stand as a group so we can recognize you and recognize your contributions. There you go. Wonderful. And we also have some members of the Hall of Fame in our audience tonight. So please don't be shy. Would you please stand as well to be recognized? Okay. And so introducing our keynote speaker, did you want to come up, Sharif, and introduce our keynote speaker? Thank you, guys.
Thank you, Devin. I'm Sharif Zadeh, and I serve as the Vice President of the SVEC of the Council this year. It's my great honor to introduce our tonight's keynote speaker. Our speaker doesn't need any introduction, but before that, I'd like to briefly mention just a few sentences about the theme of this year and our magazine cover. The topic is about climate change, so we decided to have the theme of the magazine and the publication of this year's Banquet about climate change. But I also ended up adding a small robot next to the Earth on the magazine cover as a show of impact of humans and also robots and artificial intelligence to fight climate change in the future. Also, I serve in several committees at IEEE Silicon Valley for Computer Society and SSCS as the sponsors of the Banquet tonight. And we have a new AI initiative within IEEE and ACM. And I would like to invite other engineering societies, including mechanical, civil engineering, and all the members of SVEC to join us in this new AI initiative. It's my great pleasure to introduce Dr. Stephen Chu. He is the professor of physics and professor of molecular and cellular physiology in the medical school at Stanford University, and currently is the president of the American Association for the Advancement of Science. He has numerous publications in various fields, from clean energy, polymer physics, biophysics, nanoparticles, batteries, and other topics. Actually, it was interesting over the dinner. We were talking about the comparison between the number of his preceding publication and his H index. It's very interesting. It almost match. You should go look it up. He served as the 12th U.S. Secretary of Energy from January 2009 through 2013, and he was the first scientist to serve as a cabinet member in U.S. history. Prior to that, he was the director of Lawrence Berkeley National Lab from 2004 to 2009, and professor of physics at the Stanford Universities from 1987 to 2009. He's the co-recipient of the 1997 Nobel Prize. And also, he's a member of the National Academy of Sciences and several other organizations. Without further ado, please join me in welcoming Dr. Chu.
Thank you. Good. Okay, thanks. It's a pleasure to be here and talk about something I really care about. I started this journey around 1999, as an interested citizen and skeptical of climate change, but I said, well, you know. So I started reading about it, and after a couple of years, I said, you know, there might be something there. I'm not really sold on it, and after a while, I said, no, there really might be really something there. And that's the beginning of the end. So I was a very happy researcher at Stanford, and people at Berkeley Lab, they wanted me to be director of Berkeley. I said no twice. No, I'm not interested. And let me tell you, you have to say no 3 times. It's in the Bible. And finally, the then director said, look, you know, if there's a 5% chance you're going to take the job, come. And otherwise, don't waste our time. You don't want to waste your time. So I thought, I'm here going around giving talks on climate change. And Berkeley Lab, those of you who don't know, it's just adjacent to University of California, Berkeley, not to be confused with Lawrence Livermore Lab. And when I was a student at Berkeley, I was also an employee of Berkeley Lab as a graduate student and postdoc. And it's a very distinguished laboratory. 15 people who worked there got Nobel Prizes. But that's the least impressive. The most impressive, about 36 young scientists who were trained there went on to get Nobel Prizes. Okay? Harvard has a similar record, University of Chicago, not Berkeley, not many other places. So I said, if I could join that lab and get people interested in the science and engineering that could help with climate change and technical solutions, not political solutions, it would be worth it. So, as I said, that's the beginning of the end. So now I'm going to talk about something I care about. I was going to step down after that, and you don't want to hear this. So anyway, so I'm not a politician. I didn't know President Obama. I never campaigned for anyone in my life. And in the 3rd week in November, I get this strange phone call. President-elect would like to talk to you about an important job. I'm not sure I want to talk. I'm not looking for a government job. How important? Secretary of Energy? Okay. That rises the threshold. So I met with him. I'm 20 minutes into my talk, and meet him in the 15th floor of a Chicago building. It's warm. It's okay, he's from Hawaii, so I take off my jacket, I take off my tie. He comes up to me and says, everybody's telling you you should be the new Secretary of Energy. And I say, who are these future former friends of mine? He doesn't like some of my jokes, he likes some the other. Anyway, so after an hour just one-on-one, I call my wife and say, if this man asks me to be Secretary of Energy, I will say yes. I was that impressed with this guy. And he asked me a week later, week and a half, and I said yes. And again, that's my ruling. Okay, so let me talk about why I was motivated to do this. I'm going to talk about climate change. This is data you might know of, but we're going to talk about carbon dioxide. I'm just going to start the clock at, some arbitrary date. We'll call it 1 AD, and go forward 2,000 years, and that's the carbon dioxide level, and this little arrow is where we are now. And you could say, is this a coincidence? Is this something that, carbon dioxide has gone up and down over a million years, actually hundreds of million years, and it's very correlated with temperature. So what's different about this time? Why isn't it the same? And I have to say that there is a smoking gun. Because if you look at the carbon dioxide levels of carbon-14, which is made in the upper atmosphere with cosmic rays, and it goes down to the biosphere, carbon-14 is in all of us, and it's radioactive dating, and when you die, and it's been rumored we'll have that, imagine you go in a coffin, and you're very isolated from the rest of the biosphere. The carbon-14 in your body will decay with a half-life of 5,700 years, so after tens of thousands or a million years, you have no more carbon-14 in you. It's all decayed to nitrogen. They exhume you and all your friends, me included, and they put us in a fossil fuel plant and they burn you for electricity. We have no more carbon-14, and if that is a lot of carbon, the ratio of carbon-14 to carbon-12 gets diluted. It quantitatively agrees with the amount of fossil fuel we put in. Now think about that. If your natural cycles of trees and oceans, most of the cycling times of that are less than the carbon-14 lifetime. So you reach steady state. So it had to be sequestered for tens of thousands of years, maybe a million years, okay? Fossil fuel does that. Trees don't do that. A lot of the ocean doesn't do that. So I consider this the smoking gun, that this time it's different. It's not biosphere circulation. All right. You can ask other questions. Are the glaciers melting? Is the sea level rising? The short answer is yes, but I'm going to give you a history lesson, not a climate prediction. So let's go back. On the right-hand side is time 0, where we are today, and you go backward, and you see the temperature on the right-hand side in black going up and down like a yo-yo. That's natural causes, because I can assure you 50,000 years ago, humans had nothing to do with this. You look back in the last warm period where that red arrow is, and we're about 1.5 degrees, maybe 2 degrees. That warm period was warmer by at most 2 degrees. What was the sea level during that time? How do we know what the sea level was? Well, you can look at fossils of seashell critters who live at the border of land and ocean. You can radioactively date them. Where were they living? You can't look at it in one place. You'll have to look in hundreds of places, because land goes up and down. And so what we find is that in this warm period, roughly 125,000 years ago, the sea level was 6 to 9 meters higher. So that's history, not a climate model. The other scary thing is that if you look at where we are in carbon dioxide levels today versus the prehistoric record, geological record, we have to go back 3-4 million years ago. And at that point, we're 3 degrees warmer. Okay, so this is why there's some concern. And in the sea level rise, 20 years ago, 10 years ago, we thought it would take thousands of years for the glaciers to melt. And then with satellite measurements of Antarctica and Greenland, all bets are off, because now the estimates are being rushed forward. Maybe half to 3/4 of that 6 meters higher will occur in a couple hundred years. Not to worry if you have beachfront property. That's not to worry. But 10% of the world's population lives within 6 meters of sea level. All right. There's other things that people have noticed. There's increased droughts. Water aquifers are depleted in many parts of the world, including the United States, especially in the Midwest and California. Forest fires, all this stuff. And so these are the water stress areas in the world, and the United States lights up. All right, so if there's water stress and a failure of agriculture, borderline countries fail. And when borderline countries fail, they get desperate. As we've seen, maybe 5 million refugees in Europe over the last 3 years, and then Europe is undergoing a crisis. We've seen, having nothing to do, not very much to do with climate change for sure, in Central America wanting to come to the United States because they're desperate. But in this scenario where agricultures fail and economies fail, we're not talking about 5 million, we're talking many, many more than that. When I was Secretary of Energy, I was talking to some Indian ministers who, it wasn't a debate whether climate change was happening, but they were worried about Bangladesh because it's 140 million people, very low-lying thing. They could either go to the mountains, but there was nothing, there's only poverty there. So the Indian ministers felt they would go over the border. Largely Hindu country, largely Muslim country, very, very poor, and they were desperate. What are we going to do? Do we shoot them at the border? We can't do that. Okay? So even in 2009 to 2013, there was this concern about what would happen to political stability. All right? So this red line is the line that we need to keep below 1.5, 2 degrees. And this is, the black line is where we are in cumulative carbon emissions. Why cumulative? If you stop dumping sulfur dioxide, nitrogen oxide into the atmosphere, the lakes will clean up. The acid rain goes away in 20 years. What about the carbon dioxide? Well, half of it gets absorbed very, very quickly by land, more plant growth, the oceans, and the other half kind of circulates back and forth, and we don't know exactly how long it is, but the best scientific estimate is 10,000 years. So we're not worried about 2100, we're worried about 100 AD, which is a different dimension. For that reason, we think of cumulative emissions. It doesn't go away for roughly half-life 10,000 years. All right. Let me also remind you that 3/4 of the carbon emissions occurred since 1950. And although Yogi Berra did not say that, he could have said this: if you don't change direction, you will end up where you're heading. And so in the next 35 years, 30 years, based on current emissions, we pass through this dotted line. Okay? So it's not if, it's when. And then how much past the dotted line, we don't know. So that's not good. That's the bad news. So let me tell you a little good news. It's kind of like this joke. It's probably in politics, but I'll say it anyway. O.J. Simpson's on trial. His lawyer goes up to O.J. and says, "We got the DNA tests. It's not good news. There's good news and bad news." So O.J. says, the lawyer says, "What do you want to hear first? Tell me the bad news." "Your blood tests are in, your DNA is everywhere." "Oh, that's bad. What's the good news? You have low cholesterol." So anyway, here's the good news. We can do something about it, and there's technologies that can do something about it. So if you look at this graph from IPCC, the orange at the bottom, or whatever it is, yellow, I don't know what it is CO2 emissions. But I want you to pay particular attention to CO2 from forestry, agriculture, methane, of which more than half is due to garbage dumps and agriculture, and N2O, which is due almost exclusively to fertilizer runoff. So if you look at that, there's more greenhouse gas emissions from agriculture and land use and forestry than there is from electricity generation in the world. So I wanted to draw your attention to this. And we've actually geoengineered the world in ways that it's hard to believe. Half of the habitable land in the world is used for agriculture and grazing, okay? And so let me give you examples of geoengineering. It's a quiz, I'm a professor, and the quiz is, can you pick out the native corn from the corn we eat? That's the wild corn. It's unrecognizable from the stuff we eat. Let's go to animals. Beef cattle, pigs, broiler chickens. The full circle is the natural lifetime of these animals, and the little red thing is the time when they're slaughtered. Broiler chickens, it's 40 days from hatching when they're slaughtered. Beef cattle, it's only 1.5 to 2 years before they're slaughtered. Pigs, roughly 24 weeks. And by the time they're 24 weeks, they're 280 pounds. Okay? So this livestock has been bred to grow very, very efficiently, very rapidly, in a small fraction of their natural cycle. Not only that, if you think about all the animals we breed and eat, and us, and you ask the question, think of all the mammal biomass of the world, humans and the animals we eat, and the rest of it, the mice, the rats, the lions and tigers and bears and deer, whatever. What's the fraction of humans and animals we eat to the rest? We're 96% of mammal biomass. Okay? We've reshaped the world completely. In the amount of land we've put under agricultural production, half of it, and the whole mammal world. All right. These aren't mammals. I guess they're mammals. Turkey's close enough. Slaughtered, the Safeway turkey 3.5 months after they're born. But they're not like the usual birds. They're so breast heavy and they grow so rapidly, they're not going to really reach adulthood. They'll fall over. But that, no matter, they're slaughtered very quickly, and they can't mate, so they're artificially inseminated. Now, if you wait for a big tom at 24 pounds, they're more like real birds. But let me remind you what real turkeys, wild turkeys, look like. These are wild turkeys. Now, we don't know how old they are. We know how old this wild turkey is. Wild Turkey 101, 8 years, or so they claim. Okay, let's move on. Let's talk about the carbon emissions. China is now the leader in world carbon emissions. It's double the United States today. The United States comes in, and the whole EU 28 or EU 27 plus 1 are less than that. But if cattle we eat and the dairy cows we raise were a country, they would be more carbon emissions, greenhouse gas emissions, than the entire EU 28. Okay? Kind of profound. Now, I'm not here to tell you you shouldn't eat beef. That's a personal choice. However, you probably have people at home, like your kids or your grandkids, who are beginning to realize that if they can do something in the world, as a personal choice. You know, don't drive a big car, don't even own a car, and meat substitutes. And so these are two meat substitutes, Impossible Food Burgers and Beyond Beef. There are many more. Sadly, Impossible Food Burgers are impossible to buy in a supermarket. Hopefully that will change. And there's really interesting chemistry associated with Impossible Food Burgers. I happen to know because I know the founder of this company. He was a very distinguished biochemist at Stanford. And he calls me up and says, Steve, you inspired me. I quit my job. He was a Howard Hughes senior medical advisor. I said, you did what? He said, if you are willing to become Secretary of Energy, I need to do something about climate change, but I'm just a chemist. So I'm going to make a vegetable product that could be substituted for beef. And so in the flavorings of the chemistry for beef, he found that the blood taste actually comes from the molecule for blood, hemoglobin. So he looked at various varieties of hemoglobin and found remarkably that hemoglobin from soy is pretty good. But he couldn't get enough hemoglobin from the soy roots. So he finally gave up the ghost and said, we're going to genetically engineer yeast to grow hemoglobin, fake hemoglobin, to give you the blood taste. And then they did a little taste testing with soy hemoglobin, this hemoglobin, that hemoglobin, and found that the people actually liked the vegetable form of hemoglobin better than the beef form. I did not ask him if he did taste testing with human hemoglobin. Don't want to go there. But anyway, it's not bad. They're still working out. It's improving. Let's talk about fish. This, on the left-hand side, is global wild salmon catches, and it's going down, down, down. And most of the fish the humans eat today around the world are farmed. They're not wild caught. You can tell because if you go to Safeway or Whole Foods or wherever you shop, the wild catch salmon is like 3 times more expensive than the Costco salmon. It actually tastes better too, but never mind that. So then the question is, can you feed a growing population? And this is maybe creepy for some people, but it's okay for me. They put 2 genes in salmon that were salmon genes. One gene was from Pacific Chinook salmon, and another from ocean pouch, not exactly a salmon. So these are 2 salmon. One of them is the kind of wildish sort of, or farm salmon. The other bigger fish, like 3 or 4 times bigger, is this other salmon. Now, it took 19, maybe 20 years to get FDA approval. And the deal was, there's no way these salmons get exposed to a lake, a river, or the ocean. They're on land, heavily filtered water, and that's it. And yet, this company feels, Aqua Advantage, thinks that even despite that, it's a way of getting more meat on the table for the same amount of feed. Now, for America, we can afford Atlantic cod or whatever. But for a growing world population, this is an issue. Let me also tell you about some exciting things. There's a company in the Bay Area that called Pivot Bio, and they've figured out how to get microbes that they put onto the seeds of corn, and the microbes enter into a symbiotic relationship with the corn so that it was imitating legumes, which actually fix nitrogen. And so all of a sudden, the corn is making its own fertilizer with the microbes. And with fertilizers like 2% of energy in the world. And when farmers over-fertilize, the fertilizer runs off and makes the N2O. So agriculture, because of the energy cost of fertilizer plus the nitrous oxide, is a big greenhouse gas emissions. So if you can get plants that self-fertilize, it's a very big deal. So this is now out there commercially. The company is trying to get farmers who really believe in this, and so we're in the second year of not testing, but commercial production. So that's also kind of cool. Now I want to switch gears, and as a quote when I was Secretary of Energy even before, that I'm quite fond of, it was said by the former Saudi oil minister, Sheikh Yamani, and he said, the Stone Age came to an end, not for lack of stones, and the oil age will end not for the lack of oil. That's not why he's the former Saudi minister. What he really meant is that you went from stones to other things because the technology got better. And as long as oil is a good technology, it will stay there until you invent something more. So you transition to better solutions. And if you don't find a better technical, including economic solution, and if you're a country that has trillions of dollars of money under the ground, it comes out. Okay? Let me tell you how good petroleum is. If you think of energy, on the x-axis is energy per unit weight, on the y-axis, energy per unit volume. You want energy that's compact in volume and compact in weight, and leading the charge are diesel, kerosene, and gasoline. Kerosene, jet fuel is mostly kerosene, and a few additives, so if the jet engine goes out at high altitude, you can restart it. Very important. Okay, the other thing is fat, body fat. Same high energy density, because nature figured out if you want a mobile platform, you want the highest energy density possible, which is oil-like compounds. Down here are batteries, like really close to zero, okay? But it doesn't have to be that good, because batteries actually are much more efficient. They're 95% efficient. The internal combustion engine car is only 30% efficient. So they actually come and meet not so far away. Another quiz. What does a Boeing 777 have in common with bar-tailed godwit? You probably don't know what the bar-tailed godwit is. It's a little bird about this big. And the answer is, this is 4 years old. Both can fly nonstop 11,000 kilometers. The really long-range 777s are now 1,400 kilometers. So they've outpaced the bar-tailed godwit. At takeoff, both the plane and the bird are more than 50% weight in fuel. This bird lives half the time in Alaska and half the time in New Zealand. Okay? And most of them kind of stop off in China for refueling, but then they started having really light GPS sensors on them, and they found out some reasonable fraction of them actually take off in Alaska. They fly on the Pacific, they kind of look down, they see Hawaii, and then they turn right. They don't land. And they land one skinny bird. Okay? It's amazing. I don't know how they sleep, but never mind that. Because it takes a couple of weeks. Okay. So that's just to impress upon you how good liquid hydrocarbons are. Now, in the meantime, solar and wind are really getting terrific. Solar, for example, in the Middle East, power purchase agreements. That means you get an unsubsidized bid, lots of sun, including profit, and contracts are now selling for 2 cents a kilowatt hour. And the oil and gas companies around the world and multinationals think in 10, maybe 15 or 20 years, renewable energy will be 1.5 cents a kilowatt hour, which is really cheap. However, it's not on all the time, but because of that, in addition to the solar and wind, you have to have backup power, you have to have energy storage, you have to have enhanced transmission and distribution systems. Let me also say that I think we're going to have these things. It's going to take very inventive people, but I'm very optimistic. But let me talk a little bit about just transportation electric vehicles. An optimistic view is that by 2040, maybe 55% of all personal vehicles and light-duty pickup trucks will be electric vehicles. So, why such a fast transition? Let me go back in history. This is a picture Easter morning, 1900 New York. It's the Easter parade. And here's a picture Easter morning, 1913 Easter parade. What's the difference? One car, one horse and buggy. 13 years. What propelled that in 13 years? Well, because you need a huge infrastructure change. You need better roads, you need a gasoline supply chain, you need repair shops. And what propelled it was a serious environmental problem. What's the problem? The problem was in 1880, 160,000 horses in New York City, producing 3 to 4 million pounds of horse poop a day. It's piling up everywhere. Along comes a poopless carriage. Perfect. Okay? So it was the poopless carriage that actually made the adoption of automobiles really fast. Let's fast forward 100 years. This is Beijing in a bad air day. And we're beginning to find out that PM 2.5 is particularly dangerous. And large epidemiology studies being followed up by even larger studies, all confirming that even a small amount of PM 2.5, in this case, in this study, only 5 micrograms per cubic meter, give you an 18% higher chance of getting lung cancer. The average air in Beijing in 2013 was 76 micrograms per cubic meter. So this is pretty serious stuff. Delhi is much worse. Delhi is like 300 or 400 average. And so in 2016, Beijing was like a pack of cigarettes a day. So Delhi, you're 3 or 4 packs of cigarettes a day. Everybody smokes from day 0. Here's the scary thing. Lung cancer is not the biggest problem. Just like cigarette smoking, it's coronary disease, stroke, lung cancer. So let's talk about the batteries. Will there be enough natural resources to supply the batteries? The batteries that we use today in our cell phones and our vehicles use a lot of cobalt. And so this is a projection to 2030 only, where you see the EV batteries, the portable batteries, and non-industrial batteries, and you see that there's going to be a rapid demand, and the black line is the supply. And so if EVs get really popular, they're going to get very expensive because the world is not going to have cobalt. And so the word is you've got to get rid of the cobalt. In fact, even nickel will be too expensive. The good news is the cost of EV batteries has declined tenfold in the last 10 years. It's going to decline another 2 or 3-fold. And the energy density is going to go up to here. Why am I so confident of that? Because I'm on the board of a battery company, and we're now shipping samples to companies with that energy density. So it's not a laboratory thing, it's a production thing. And so that's very good. And so the energy density will double. The price, I think, will go down at least another 2-fold. All good news. Let's talk about the natural resources. Right now, today's batteries, let's say the Tesla, the materials are about 30% of the cost of manufacturing. Will we run out of lithium and will we run out of cobalt? The answer to cobalt is yes. And so in order to get the price down, continue to drop down, you need to think about lithium supplies. This is a projection to 2030. and what's going to go on. So in one, it's personal research that I've publishing, we've just submitted the paper with Chung Lu, who's now an assistant professor at the University of Chicago, with Yi Shui, who's a professor at Stanford with me. And so we've just submitted this paper where we're showing that you can extract lithium from seawater, hopefully economically. The cost of electricity is about 50 cents, the cost of lit per kilogram. The cost of lithium is about $10 to $15. And seawater, there's 5,000 times more lithium than in brines and ores. So this is good. So maybe this is under control, and we're working on making sure that this process cannot be poisoned and can go many, many cycles. All right? What about the cobalt? Cobalt, you know, anticipating success 30, 20 years from today, you can't use cobalt or nickel. And so the important target or wish list is you have lithium, which I think is solved, with sulfur. And there are eyeballs with sulfur, because you got to get the sulfur out of fuels for low sulfur fuels. So piles and pounds of sulfur are building up all over the world. I advise Royal Dutch Shell, and they're trying to get rid of their sulfur. They stick 40% of their tar they make for roads are sulfur, because it's filler and it's free. Okay? So if you can make a battery of lithium metal and sulfur, you're good. But the trouble is, in the sulfur lithium, if you want to charge the battery, which means you got to get lithium back to the anode positive side, some of the sulfur comes along with it, and it poisons the battery, and it gobbles up the lithium. And so the issue then becomes very clear. If you want sulfur for scale, you got to get a better separator that separates the sulfur from the lithium as it comes over. And so we're working on it. I'm very, very optimistic. And this is a separator. I'm not going to show you the real data of the batteries, but we've got 1,000 cycles of lithium sulfur metal, but it decreases its capacity by about 50%. We got to get it to only 20%. And if we can do that, this has hope, okay? The batteries get cheaper and cheaper. Electrochemistry, I'm not going to go into this. This is electricity to make chemicals. And I know you're not mostly a technical audience, but so here's the deal. You're mostly engineers, right? Anyone an engineer here? Yes. So if you want to convert something into something more valuable, you want to give energy into it, as opposed to fossil fuel. So we're in the carbon business. You take fossil fuel, oil, natural gas, high energy value, you go down and you make stuff. You make power, you make plastics, you make everything. If you start at the bottom, carbon dioxide, really stable. In order to get carbon dioxide or water up the chain, you got to give it energy. And so you need cheap energy in order to go uphill, in order to take advantage of the fact that you're going downhill the other way. And so the great thing about this is, with really cheap electricity, you begin to think about going uphill. That's the only takeaway message. In terms of splitting water, if it costs 4 or 5 cents a kilowatt hour, it's impossible. The amount of energy costs more than the hydrogen you want to make. At 1.5 cents a kilowatt hour, it's less than half the energy. Good deal. So then you begin to think of electrochemistry only because electricity is becoming cheap. You may not know, but let me remind you that virtually all chemicals in the world are made by thermochemistry, not electricity. Chlorine's made by electricity, aluminum's made by electricity, that's it. It's all thermochemistry, because electricity was too expensive. So when electricity becomes cheap, there's hope. All right, So what's the deal? What is the dream? You take carbon dioxide and water, you pour in energy in various mechanisms, thermochemical, electrochemical, we don't really care. You make hydrogen, you make CO, you make oxygen. And in the end, you want to make liquid, remember the bar-tailed godwit and automobiles and airplanes, especially airplanes. You need liquid hydrocarbons. So how much does it cost to ship oil and store crude oil and halfway around the world and store it? And the answer is, if you amortize that over the cost of the transportation and storage, is 2 cents a gallon of gasoline. Slow tankers are nearly free. So these super tankers are really an intercontinental transmission line. All right. I'm nearing the end, but I'm here to talk about climate change, but really writ large sustainability, water, agriculture, climate, energy. And in order to live a really sustainable world, the world population just can't increase forever. Okay. However, if you think about it, increased economic prosperity and global competitiveness, you ask any economist and any politician, they actually say we need more young people to have a smaller aging population. And they're so alarmed when the population in, let's say, the Midwest is declining because the economic competitiveness is growing smaller. How do you preserve the economic vitality? All right, so let me step back and say this is known as a Ponzi scheme. You have more people that you shall sell shares to, and it's okay. Okay, so let me tell you some good news. It turns out, and there is, in the red is India, in the green is Mexico, and in the yellow is Germany. And on the x-axis is national income, GDP per average person. And on the y-axis is the fertility rate. What does that mean? It means, on average, for every woman in that country, 2.1 is break even. You think 2 is break even, but there's mortality, so 2.1 turns out to be break even. And here's the amazing thing. India is not rich. Its mean GDP at this time, 2018, was $3,800 a year. And yet the fertility rate is very close to break even. Okay? We know in OECD countries, the United States and people like that, it's very negative. The United States is not quite negative because we have a large immigrant population. But the thing is going on is that we have a natural birth control. We can speculate as to what it was due to, but it's certainly due to women's education. It's certainly due to the lights are on at night. There's late night TV. There are other things to do. That seems to help. And of course, you know, when you get wealthy, you're thinking, oh my gosh, I have to pay my kids to go to college. And then even after college, they'll hang around. So whatever, I don't care. But it's happening in poor countries as well. So this is a natural thing. However, think about this. This is natural birth control. This is good, okay? So point number 1, how do you increase prosperity with declining populations? Japan is going to face this. Their replacement is like 1.2, really strongly negative. And so how do you have a declining population as you get older and you only have one kid and that kid is halfway around the world, and who's going to take care of me? And oh, by the way, who's going to help me get out of bed? Who's going to help me wash? All this other stuff. And so we have the means, maybe, human-assisted robots to help you get out of bed. It's like, you know, autonomous driving, that's not going to actually decrease the carbon footprint, but it means that as you get older, you will still have your mobility. okay? So if you have human-assisted robots, they can help you take care of your parents because you don't have the physical strength to do this. This is a good thing. So we've got to figure this out, and we've got to start thinking about it. But the other thing is that we need a different measure of wealth. Because if you use just GDP, GDP is measured on how much you produce, which requires you consume it. 1 car per family is not enough. 2 cars per family is not enough. 1 car per adult, you begin to saturate, which happens to be the US norm of 1 car per adult if you include all the pickup trucks and everything. So the consumption of stuff is not going to be good because it gets you on this, continues the Ponzi scheme. I would say that a better definition of wealth would be quality of your health, especially in old age. Education, including after K through 12 and maybe college, you actually have continuing education as the world turns and technology transfers. Stress level. You're worried about your kids. Are they going to be shot in school? Is my neighborhood safe? Connections to family and friends. So you need more than just GDP stuff to measure wealth. As long as you use wealth, everybody gears, and all the politicians will say, more stuff. And this is not tenable. So let me close by telling you something remarkable that happened in the last 20 plus years. This last year's Nobel Prize to physicists, 2 of them out of the 3, were for their discovery of so-called exoplanets, planets beyond our solar system. And the latest estimate from the serious literature is there may be in our own galaxy 10 billion Earth-like planets. Earth-like means there's liquid water, not too heavy gravity, so it's not oppressive atmosphere, not too light a gravity, so you won't have any atmosphere. Mars is too light a gravity. That's a lot, 10 billion planets. So this is great. That's our Milky Way. You know, we're here. This is taken with a wide-angle lens. And suppose, if you look at the probability, you maybe want to go 1/5 of the radius of the galaxy to find another Earth-like planet to colonize after we've trashed our planet. Okay? So let me remind you how you get out of the solar system. It's not by rocket fuel. You actually go by nearby planets, and the satellite goes in and whips around the planet, but because the planet is moving, it gives you a little boost. So you get boost, boost, boost. And by the time you get out there, you're going pretty fast. And in the graph on the right is actually the velocity of things like Voyager and these other things. And you see, as you go out of the gravitational pull of the Earth, it slows down. You whip by a planet, you get this little spike up, and it slows down. You get another spike up, and it slows down. If you really wanted to maximize the boost and not kind of look at the planets while you're going by, you can probably, instead of 20,000 kilometers a second, you can probably get up to 70 kilometers a second. That's really fast. 20,000 kilometers a second. Okay, how long does it take to get out of a galaxy? 45 million years. To get to 1/5 of the radius of the galaxy. 45 million years is a long time. Nothing we've made lasted 5,000 years, let alone 5. Okay, here's the other problem. You're now going 70,000 kilometers a second. You get to your planet, how do you land? Violently. Okay? So, let me close with one of my favorite pictures. It's taken on Christmas Eve, 1968. I was a college student. And it was called Earthrise. And after the last orbit around the moon, the capsule turned earthward. And the astronauts actually had handheld cameras to take these pictures. And the astronaut who took this picture, Bill Anders, said, "We came all this way to explore the moon. The most important thing is we've discovered the Earth. Think about it. Moon is not a good place to live. No air, no water, no magnetic field to shield you from cosmic rays, so you get a lethal dose of radiation. I hope I convinced you you ain't going somewhere else. And so this is a wonderful planet, but in the years since 1968, we've found that we've altered the destiny of the planet. It is largely caused by humans, and we have to take care of this one because there's really nowhere else to go. Thank you. These AV guys are good.
I wanted to go through certain things about organization, and what you see here are all Hall of Famers. And I didn't finish my part, and so I just want to thank every one of you Hall of Famers for coming here and being with us today. And this we went through, I already spoke about it, but I just also wanted to mention about this, what it means to serve on this organization. And I didn't talk about mission and vision, that I just want you to know that we are an organization that have a mission and a great vision for the future of our new generation and ourselves. And I want to introduce you to the new board of 9020 because we didn't finish earlier. So I am Yolka Masada, I'm the president of the organization. Mujaba is here. I want to introduce the board to come here. Mujaba, where are you? And Meron. John is not here, and Varam. And so. And we went through this organization, and the programs that we do is, they say some Hall of Fame. Engineers Week Banquet is that covers Hall of Fame. We do discovery, outreach, education awards, STEM programs, and grant and awards for K-12 and our open house. And then this we talked about, so I just don't want to talk much about it because we already went through. And a speaker. Now, before we go to the Hall of Famer, I want to introduce you to our Hall of Fame, Terry, to come here and present the Hall of Fame. Hold on, just the screen moved. Where you have the introduction, you have the introduction of you. Because you also are Hall of Famer. Do you want me to read that? No, I don't have it. Yeah. Oh, you don't have it? And just I want to say that there is also a Hall of Fame recipient of 2011. So we selected him as our key person to present the Hall of Famer to the new inductees.
Thank you. Thank you very much. Good evening. The Silicon Valley Engineering Hall of Fame aims to celebrate the accomplishments of engineers and technical leaders in Silicon Valley, particularly those who have demonstrated outstanding professional achievements and have made significant contributions to the success of our Silicon Valley community. The Council's Hall of Fame Awards Committee selects inductees and reviews submittals made by a variety of methods, member professional societies, by corporations or individuals. Inductees are selected on the basis of professional achievement, service to the profession, and service to the community. I'm going to be introducing each of these, the two people who will be inducted this evening. I will introduce them to you, and then I'll ask them to come up and receive their plaque, and we'll do a photograph. So let's meet this year's inductees. Our first inductee is Dr. Fred Perez. Dr. Perez is a passionate participant in technology, an innovator, an entrepreneur, a high-tech company founder, a distinguished educator, and a mentor to aspiring young engineers. After earning his PhD from Cal Berkeley at the age of 25, he started a career in Silicon Valley. Advancement in storage device technology has enabled ever more functional and affordable storage devices with dramatic impact on virtually every aspect of our life in the modern society. Dr. Perez designed, developed, and manufactured a variety of products for the data storage device industry, in particular, the design of a unique servo clock head to increase disk file storage. Virtually all documents and photos stored in the clouds utilizes technologies developed by Dr. Perez. Dr. Perez is currently the chair of aviation and technology and a professor of mechanical engineering and past chair of mechanical and aerospace engineering at San Jose State. His energy and enthusiasm for engineering has inspired countless young people to consider the engineering profession. As a faculty member and a scholar, he has a variety of research interests. To name a few, electronic packaging, semiconductors, smart home systems, energy efficiency, self-driving automobiles, autonomous vehicles. As a gifted educator, he has introduced over 35 new courses in support of the workforce development in Silicon Valley, a remarkable accomplishment. He has developed educational research laboratories, supervised graduate students, and published journal and conference papers. He is a member and active contributor to several professional honorary societies. He is a co-founder and past president of this organization, the Silicon Valley Engineers Council, co-founder and president of SIP, which I understand is the Society of Iranian Professionals, and Project Enable. He has served as president of the ASME Santa Clara Valley section. He's a life member, a fellow, and a recipient of ASME's prestigious Dedicated Service Award. He is a life member of the Chinese Institute of Engineers. Remarkable. And a co-trustee of Epsilon Pi Tau, which is the leading international honor society for technology. Dr. Perez, in recognition of your many contributions to the engineering profession, and as an enthusiastic educator, as a practicing professional, and as a role model for service to support of our Silicon Valley community, we are pleased to induct you into the Silicon Valley Engineering Hall of Fame. Please come forward.
Good evening. How do you top this fantastic talk with a Nobel laureate? I think the best thing, as they say, is the next best thing to intelligence is silence. Maybe I should just stay silent and don't say anything. But I think you deserve it to be here, and I'd like to thank a lot of people who have helped me to get to this point. First of all, I'd like to thank Dr. Shoup for your kind introduction. I cannot be more pleased than to have you to make this introduction. Dr. Shoup was a former dean at Santa Clara University, and we go back almost over 30 years associating with each other. I would also like to congratulate Mr. Ajit Manchua for his induction into the Hall of Fame. I am honored to be recognized by the Silicon Valley Engineering Council Hall of Fame Committee. it truly is an honor to be inducted into the Silicon Valley Hall of Fame. I would like to thank my nominator. I would like to thank my references for writing strong letters of support. I would like to thank Dr. Stanley Meyer, the chair of the Hall of Fame, and I would like to thank the judges of the Hall of Fame committee. I would also like to thank my family at these two tables in front, my industry and academia colleagues for giving me the freedom and to mentor me over the past years. I would like to thank the late Dr. Werner Goldsmith at UC Berkeley. He was my thesis advisor. He really made a profound impact on my life and my career. I would also like to thank Anil Nigam of Memorex Corporation, who gave me the opportunity to embark on a career in electronics packaging, the area that is unheard for mechanical engineers a few years back. He was a good mentor to help me apply my education to my career opportunities. I would also like to thank Mr. Peter Bischoff, co-founder and vice president of engineering at Reed Rod Corporation, who encouraged me to take a chance to start my company. Mr. Bischoff provided endless support throughout my career. Thank you, Peter. I would also like to thank Ann Walker, my colleague at Reed Rod Corporation, who supported me when I started my own company. Having started my career in Silicon Valley, the center of innovation of the world, as you heard from Dr. Chu, I met and worked with some of the most brilliant individuals in the Valley. We worked on this storage system of 5 megabyte capacity, of the size of a refrigerator, to multi-terabyte storage devices that you can hold in your palm of your hand. I am proud to have made contributions in the field in Silicon Valley, the opportunity that creates. Silicon Valley provides great opportunities to constantly evolve individuals, and I'm one of those individuals. My career has evolved from working on disk drives to electronics packaging and now autonomous and self-driving vehicles in industry and academia. I would like to thank my colleagues at San Jose State University, Dr. Raghu Agrawal, Dr. Ji Wang, Dr. Alex Linecki, and Dean Jay Penson for their support in accepting me as a colleague in the department. Thank you, Raghu, thank you, Ji, and thank you, Dr. Linecki's family. I also like to thank Dr. Taren Shu of the Mechanical Engineering Department, who encouraged me to take chances in the field of autonomous driving, which was very rare a few years back. I would like to thank Dr. Ji Wang and Professor Mokri for their unwavering support in this field. Thank you, Dr. Wang. Thank you, Professor Mokri. My goal is to educate and provide skills to many students to contribute to the workforce in Silicon Valley and beyond. Throughout my academic career at UC Berkeley, Mission College, West Valley College, San Jose State University, I can proudly say that I have positively affected the lives of over 8,500 students. A simple positive response from a current student or an alumnus gives me the fuel to motivate me to do more. As was stated by Dr. Terry Shu, the Hall of Fame inductees are expected to have demonstrated professional achievement, have made significant contributions to the profession and the Silicon Valley community. I strongly believe that I have achieved these goals and will continue to do more. Thank you again for this honor. I am very grateful. Thank you.
Let's meet our second inductee, Ajit Manocha. Throughout his career spanning 4 decades, Ajit has been a pioneer, a business leader, a champion of industry collaboration, and that as a means for advancing technology for societal and economic prosperity. He has been uniquely adept at forming strong partnerships with customers, suppliers, governments, and countless communities for these efforts. Ajit began his career as a research scientist at AT&T Bell Labs, where he was granted over a dozen patents related to semiconductor manufacturing processes. And these have served as the foundation for modern microelectronics manufacturing. He went on to hold senior worldwide operations leadership roles for Philips Semiconductors, Spansion, and before serving as president and CEO at Global Foundries and SEMI. He has served on the boards of SEMI, the Semiconductor Industry Association, and the Global Semiconductor Alliance. Ajit was an advisor to President Obama on the Advanced Manufacturing Partnerships Steering Committee on the President's Council of Advisors on Science and Technology. In 2012, during his tenure at Global Foundries, Ajit was awarded the prestigious Environmental Health and Safety Achievement Award. Additionally, he has shown a passion for people development by teaching courses such as Leadership by Example and Classroom to Clean Room to Boardroom. Currently, as president and CEO of SEMI, Ajit has initiated a major transformation to expand that organization's scope and influence to represent the broader electronics manufacturing supply chain. He has positioned SEMI to tackle major challenges facing the industry and to support the community by building up workforce development and diversity and inclusion programs to address the growing talent shortage and lack of gender parity across the industry. In December of 2019, Ajit was named an all-star of the semiconductor industry by VLSI Research for his visionary leadership in restructuring SEMI from its traditional position to represent the expanded electronics supply chain. Ajit Manocha, in recognition of your many contributions to the engineering profession as an energetic professional, as a visionary leader in key industries that have shaped the region, our nation, and the world, and as a highly gifted role model for others to emulate, we are pleased to induct you into the Silicon Valley Engineering Hall of Fame. Please come forward.
Good evening. I'd like to thank the Silicon Valley Engineering Council for the great honor. Also, I would like to congratulate my fellow inductee, Fred Berez. Let's give him a big hand again. As I think of others who have been here on this stage before me, the real legends of Silicon Valley, such as Gordon Moore, Bob Noyes, and other greats, I truly feel honored and humbled with this honor. I'm here today before you guys, standing on the shoulders of those giants that I mentioned, and many more I didn't mention. Now, I will spare you from my long career history, but my personal history is probably somewhat more relevant. I grew up in New Delhi, but I knew that I wanted something more than what India could have offered me. I left India in mid-70s and came to the US for graduate studies. And I borrowed $100 from my cousin, the only one person I knew in the US, to start my life in US. And I was fortunate to land in Bell Laboratories as my first career job in USA in 1980. Bell Labs then was the hotbed of innovation, and that also with the gathering of so many brilliant minds that propelled me on my journey and eventually landed me here in Silicon Valley, perhaps which is the greatest innovation hub in the world. I wore many hats throughout the years, from researcher in the lab to a CEO of a multi-billion-dollar enterprise, and every role in between. But there was one constant in those roles, and that has been my passion for learning and my desire to contribute. In my current role at SEMI, quite a few friends here from SEMI, I'm fortunate to be able to dedicate myself completely to this, leveraging my expertise and giving back to the industry that I grew in. To my team at SEMI, I thank you all for your support as we continue our mission to help the electronics ecosystem to connect, collaborate, and innovate. Our work together on behalf of the industry is a huge part of this honor, and so I share it with you guys at SEMI. As 2020 also marks the SEMI's 50th anniversary, this will be a year of celebrating our industry's remarkable achievements of the past half century, but more importantly, it will also be a year of looking to the future. This is an exciting time to be in this industry. As I look back at the leaps in the technology achieved in the last 5 decades and the impact they have had on society, I'm amazed by the progress already made and even more weighted by what's ahead. It's awe-inspiring to consider what will be the impact of AI, quantum computing, 5G, maybe 6G, autonomous machines, and even the convergence of electronics with biotechnologies. I'm hopeful these advancements will improve lives and increase prosperity for all. Perhaps I'm geeking out. Sorry, I couldn't help. Well, I'm so happy that my family is here. And in fact, my complete family is here. None of this would have happened in my career without my lovely wife, Vanita, my wife for the last 42 years. And she has been unconditionally supporting me for all my career with, I don't know how many million miles and hundreds of trips around the globe while she was raising our 3 beautiful children and taking good care of them, gave them good education. And these 3 great children also have done very, very well and loved me and supported me throughout my professional journey around the globe. And 2 son-in-laws, very lovely, very dear to me. Now, this was my investment on children. And the ROI of my investment on children was 3 grandchildren. And they're here. And actually, they're trying to figure out what does our grandfather do at SEMI. And they really ask me very intriguing questions. They're still in preschool, but I can't wait for them to find out one day. And why I'm telling you all this? This particular honor bestowed upon me by the Silicon Valley Engineering Council tonight feels a little different than the many accolades and honors I have received in the past. This recognition will be a legacy that I leave behind to my children and grandchildren, and hopefully inspires them to reach greater heights and find new vistas. You hearing me, Amara Devan? Family, you have been and will continue to be my greatest inspiration and motivation, and I love you all. Finally, to the young engineers here tonight and around the world who are starting their career now at this time of so much promise, but also great challenges, I leave you with a call to action. We need your passion, hard work, innovation, and collaboration to solve the immense challenges of the day, to reshape our future and help improve the lives of people around the globe. We have so much more to do, and I dedicate this award to all of you. With that, I'll say thank you for helping to celebrate this honor today. Thank you very much.
I have one other very pleasant duty to do before I leave the stage this evening, and that is to present to the president of the Silicon Valley Engineering Council a proclamation and a special congressional recognition. The proclamation is from Lisa Gilmore, mayor of the city of Santa Clara, and the congressional recognition is from Congressman Ro Kahana. These are both in your program. We've arranged for you to have your own copy to take home, so they're in the program. I won't read them to you, but they are very special to us, and I'll ask the president to come forward so that she can share these with her board.
Good evening, everyone. I'm Rose Margaret Ekengitwa, Professor of Engineering at Ohlone College and a Director of the Silicon Valley Engineering Council. Educators, especially STEM educators, are key to the continuation of the profession, the STEM profession. In particular, K-12 educators pour their hearts into training our children so that they will continue the profession that we all so much love. The Keeper of the Flame Award goes to individuals who have stood out in their innovative pedagogy in providing great interventions to make sure that K-12 students are fully engaged in engineering, science, technology, and math. So it gives me the utmost pleasure and honor to award the Keeper of the Flame Award to the following individuals: Hector Albizo, Irvington High School, and Soriniagu Independence High School. The next award is the Discover E Award. Outreach is extremely important, outreach to the elementary schools, middle schools, and high schools. The individuals that have been awarded the Discover E Award are individuals that have stood out in their outreach programs and have relentlessly, continuously tried to engage elementary school students, high school students, and middle school students. We owe a lot to these individuals. The Discover E Awards go to the following individuals: Srinivas, Claire Delaney, Stephen Widmark, and Gina Donsmore.
Good evening, everyone. My name is Tom Tafoya. I'm one of the new members of the Education and Scholarship Committee. We've worked very hard to recruit students at both the high school and college level. To begin with, first I want to honor a few of the sponsors of this award, without whom we would not have so many awards to give out. And following that acknowledgement to the sponsors, then we'll bring up the students to present their awards. There's 10 $1,000 awards that we will be handing out. So first, I would like to ask to come up Yervent Sorian, who is the Vice President of Membership of the IEEE Computer Society. Would you please step up so we can present and have photos? Thank you.
Good evening. I'd like to, on behalf of the IEEE Computer Society, I'd like to congratulate the Council for this great event and also encourage the fact that we are acknowledging students and acknowledging education. That's the fundamental component that we all need in order to feed our pipeline and reach the Hall of Fame as we move forward. I'd like to congratulate both of the acolytes of our the Hall of Fame. Thank you for being with us tonight. Yes, of course. So the President is reminding me that the IEEE Computer Society is a sponsor of this event as well. And I'm pleased for that.
All right, and then the next sponsor that we would like to acknowledge is Sharif Zadeh, who is a member of the IEEE SSC, and I missed the last letter, but I'll let Sharif take care of that. Please, Sharif, thank you.
Thank you very much, Tom. I think I already used up my time, but thank you very much, everybody, for attending tonight's program. We are glad to be a sponsor of the SVEC, from IEEE, and we'd like, as I mentioned earlier, we'd like to invite all other engineering societies to join us in our new initiatives at SVEC. And thank you very much.
Thank you. And thank you again. And last, and someone who's been a major driver of all the efforts here and the what I like to think of a very successful and pleasurable event tonight, Yilka Masada, President of the Silicon Valley Engineering Council. Yilka.
Thank you. Thank you all. Thank you, Tom. We are honored to have this team here and members, all of you, to join us and come share this celebration. And our Vice President of IEEE, and I, as such, I am also a chair of IEEE Computer Society. And we sponsor education and work very closely with SVEC. And we highly promote education and all our programs, and we are thankful to all of you for your support and for being here with us. So thank you.
Call the names?
Yeah. Call them now. Bring them all 10.
Yes, Rose. Oh, yeah.
You call scholarships and he will...
No, we need to have
Yes, I
those
get
two,
it. I get it. And one more important member, Rose Margaret Itwa. She was one of my colleagues working on the selection, worked very hard, and certainly our success is due in part to that, because the last stages of making the final selection was quite difficult. So I want to thank Rose Margaret as well. Thank you. And next, yes, please, thank you. Please, we need applause. And moving ahead quickly, I'm going to call the two tables of award winners. We'd like the individual student to come up to receive their awards as a group. So I'll call your names, and then please come up. I'll call all the names. Yes, would you help me? So first, I would like to call up Christopher Chu. And next, Bryson Delph.
Go to the other side, yes. Because we're going to kind of you guys together.
Okay, we ready? All right, Bryson. Bryson Delph, if you would please come up. Okay, apparently Bryson is not with us. Next is Eric Estrada, who I know is here.
Congratulations.
Could you stand and take a photo and then
Just show your certificate. Thank you.
All right, very good. Thank you, Eric. And next, I'd like to call up Luis Garcia. Please come up, Luis. Okay, thank you. And our next scholarship winner is Xiomara Quiñones. Xiomara, if you're here, please come up. There she is. There she is. All right, very good. Next, would Nikolai Stifel please come up? Thank you, Nikolai. All right, Nikolai, thank you. And next, we have Jing Wen Barry Tan. Barry, please come up. Ah, there you are. Congratulations. All right, congratulations, Barry. Next, we have Stephanie Torres. Stephanie, please come up.
Photo? Yes.
Congratulations, Stephanie. And next we have Alexis Velasquez. Alexis, please come up. Thank you.
How are you?
Nice to meet you. I'm doing fine. How about you?
Congratulations.
Thank you,
Let's
sir.
do a photo.
Thank you.
Very good, very good. Congratulations, Alexis. And last, our last winner is Miss Yu Ching Ruby Sung. Please, Ruby, come up.
So, can you guys stand over there? Because we want to be.
Is there a closing?
Yeah.
Shape-wise, we're not going to put over there.
Yeah. All right. Okay, and I think this is just our closing. I'm not sure if it's for the photo or what, but it's good to have this little group session. I'd like to say it's been my privilege to work on the Education and Scholarship Committee and to identify the new talent to follow all the senior talent that we have been exposed to tonight. Congratulations to you all. Oh, yeah.
I also want to say a few other words. All this would have not been done if that was not for Tom. Thanks so much for Tom and Rose. Come here. So they went above and beyond to find students, and we are so proud that today we award 10 scholarships to deserving students. Thank you. And thank you to my Computer Society Vice President.
Yes, yes. Okay. Now we can go. So let's
So
have
they might be go up that way because they're out there.
Sure. Yeah.
Students? Oh, I see. One more. Yu Ching, one more. Can you get him on?
Yeah, I think I'm hitting pretty.
We had this opportunity, and I was in town.
Thanks for the support.
Thank you for
Yeah, we had a
support.
little. Yeah.
Yeah, you know, we had a very
Yes, exactly. come to the front, maybe,
Yeah, it's okay.
because you're hiding.
No, you're not. I put you in
No?
so you can.
Okay. You want to say something for closing?
MC is going to close the program.
Who's closing?
MC.
Oh,
Yeah.
yeah. But
Thank you
first,
very much. So
but
we're gonna
first
close.
we let the MC to close. But thank you all the sponsors and all the attendees and all the Hall of Famers and everyone that without you would have not been done. Hope to see you again next year in 2021 Hall of Fame. So we are very proud of you and thank you for everything.
Thank you, everyone, for coming tonight. Just one final word. If you parked, you can get your parking ticket validated on the floor beneath us. You may want to do that before you leave. Thank you, everyone, for coming tonight. Thank you for your patience and your support of the organization. Thank you so much.